Okay, to add and subtract polynomials is really pretty easy, and guess what? To add polynomials, you already know how to do it, because we just did it in the last lesson. To add polynomials, all you have to do is combine like terms. Now remember, to be like terms, they're going to have the same variable and the same exponent on that variable. Now the only difference is that when we add polynomials, it looks different, because we say, well, here's a polynomial, 3 terms, trinomial, degree of 2, so it's quadratic. And this is a polynomial. The only difference when we add, the only difference is that we have to put in parentheses. But we do everything the same. Here's a like term, here's a like term. 4x squared, 2x squared, 6x squared. And what I like to do, and I would recommend, is to indicate which ones are like terms. Now you might be saying, well, why didn't the exponent change? Because when we add polynomials, the exponent does not change. It doesn't change until we multiply. We'll talk about that in the next lesson. So 4x squared and 2x squared is 6x squared. I have a 6x and a negative 9x. And I like these little, what I call kind of dishpans. If I ever have any negatives, make sure that gets included. So 6x and negative 9x is minus 3x. Then I have a 7 and a 1. Add those together, and I get 8. I've just added polynomials. Pretty easy, huh? Okay, look at number 2. T squared, 3t squared, 4t squared. Negative 6, positive 11. Oh, shoot, 6, 7, 8, 9, 10, 11, 5. Okay, see what we're doing? Try the next two. Go. Now, number 3 was trying to be a little tricky. Did you notice that? So I had these two were like term, 9w to the third and 7w to the third, combined to 16. But 8w squared did not have a like term. Nothing to combine with. 4 didn't either. Okay? Over here, we did have like terms. And notice our exponent does not change. That's really important. Now, when we subtract polynomials, it's the same thing. We just have to be aware of one little thing. You know that subtraction? That's that high-maintenance friend. Addition is your wonderful friend, easy to get along with. Subtraction always throws problems into it. High maintenance. Okay, so remember that subtraction also means to add the opposite. So you have to remember you're subtracting everything that comes in that quantity. So when you subtract a polynomial, this is one option you can do, is change each of the terms that follow the minus sign, to its opposite. Then you just combine like terms. Combine like terms. Oh, I'm supposed to say add the variables. Whoops, sorry about that. Then add the like terms, the monomials, which is just combining like terms. Okay? So it has to be the terms that follow the minus sign. So what we're talking about here is that if I'm going to subtract this, what you have to remember, and I know some of your minds are going to go, why do I have to change all of them to opposites? Because you'll make less mistakes. But what you need to understand, the concept is I am subtracting everything in there. Everything gets subtracted. So if I don't change the signs, I have to keep in mind, I'm taking 2x cubed minus x cubed. I'm subtracting that. It gets really confusing. You'll see that in just a second. This one's not bad. 2x cubed minus x cubed, that's x cubed. I'm not going to change the sign. I'm going to show you without it first. Then I have a 5x squared, and I have a negative x squared, but I have to take 5x squared minus a negative 8x squared. Wow, that's a lot. But if I just change the sign, it makes it much easier. So what we're saying we do is we're going to change this sign and everything that follows it to its opposite. So I change x cubed to a negative, minus x squared to a positive, and 11 to a negative. Or you can just remember you have to subtract every term. It just gets pretty confusing, so be careful. I like to change my sign. 5x squared plus 8x squared is 13x squared. It's going to be the same answer either way. Negative 3 and negative 11 is a negative 14. Hey, let's put this on here. Oh, whoa, whoa, whoa. See my mistake? Look at that. Those are not like terms. Whoops, whoops, whoops. Hold on. Not a like term. See, if I start getting cocky, that's what happens. So minus 3x, and then I just have this negative 11. Minus 11. Okay? Well, that was helpful, wasn't it? Okay, let's do this next one. First thing I'm going to do is I'm going to go through and change the signs. I'll leave that up to you. But remember, I have to subtract everything in here. I personally like to change everything to its opposite. See how quick that is? Cross the line, change the sign. Now I'm just going to combine like terms. Now I just use my rules for addition. So I get a negative 8v to the third. I'm going to be more careful. 6 and 7 is 13v squared. Negative v, this time I've got it, minus 4v. Okay? Okay, you're going to try the next two. Go. Okay, so on these, you combine like terms. And you would have gotten 28d to the third. And negative 30d squared minus 3d. Here, if you haven't paused, you haven't done it, go now. You get negative 2x squared plus 4x minus 7. Let's go to the next page. So now we're going to see where we might actually use this sometimes and where it's going to show up in different tests and everything. One side on a triangle is 5x minus 3. The other side is x minus 4. Find the missing side of the triangle if the perimeter is this. Well, if we're talking triangles, I always draw a picture. You're going to learn that very quickly when you take geometry next year. One side is 5x minus 3. The other side is x plus 4. We don't know this side. That's what we're going to find out. Well, we know that the perimeter is equal to 8x plus 9. Okay? So basically what we're doing is we're going to look at all of our x's, and we have to come up with an 8x. If I were you, I'd just kind of do this one logically. I can show you mathematically how you can do it. Well, okay, I'll show that in just a second. But look, 5x plus 1x has to equal 8x. Okay? So you could just go 6x equals 8x. What else do I have to do to this? I have to add a 2x. Okay, so what am I going to add to this? I'm going to add a 2x. Okay? Now, I have negative 3 plus 4 plus what gives me 9? Negative 3 plus 4, so that's 1. What do I have to add to 1 to get 9? 8. So that's one way. Just kind of think logically. The other way I can do it is I could take 8x plus 9 minus, and then I would take this and make it a polynomial, 6x plus 1, and I could subtract. And again, I could just change my signs, and I can come up with 2x plus 8. So this is just kind of thinking through this is algebraic. Okay. So now find the perimeter of a rectangle. Draw a rectangle. My length is 3x plus 5. My width is 4x minus 7. But be careful, I want perimeter. So remember, I have to know this side too. So to find the perimeter, you need to know all of the sides. You can write it out. You can also just kind of go around 3x and 3x, that's 6x. 4x and 4x, that's 8x. So that's going to give me 14x. Then I'm going to take 5 and 5, which is 10, plus negative 7 and negative 7 is negative 14. So that gives me a negative 4. That's my answer. What I'm supposed to do is you're supposed to write all of this stuff out. 3x plus 5 plus 3x plus 5, okay, plus 4x minus 7 plus 4x minus 7. Or you can put it as 2 times 3x plus 5 because you have 2 of those. And 2 times 4x minus 7. You can do that also, whatever hits you. Find the perimeter, okay? Your homework on this is this worksheet right here. Okay, this is kind of the first part of what we did as far as the terms. You're going to tell me, you're going to write it in standard form, then tell me what the polynomial is based on degree and number of terms. So just like on the worksheet that we were doing, this table here and these problems here, that's what you're doing up here at the top. Then on these, you're going to add and subtract. So just be careful with what those are. You'll notice that I took off this whole side. So then if you need more room, you can use this over here for more room. Okay, good. That's it for the first section of Unit 7. So if you have questions, you know where to find us.